All right, hi everybody. Just want to make sure that you understand the ionic bonds work that you all did yesterday, and specifically that you can answer that exit ticket question: how do ionic bonds follow the octet rule? To do that successfully, you needed to have understood what the octet rule is, and then how ionic bonds are a strategy for atoms to achieve the octet rule. So firstly, the octet. The octet stands for 8, and this indicates that atoms like to have 8 valence electrons. Valence electrons are the electrons that are in an atom's outermost electron shell. So for this sodium atom down here, okay, here's sodium's nucleus. I just put Na in the nucleus so you can tell what atom it is. And this looks like a Bohr model. So we've got 2 electrons in the first shell. That can't be its valence shell. 8 electrons in its second shell, and then 1 single electron in its outermost shell. This is its valence shell. So the number of valence electrons that sodium has is only 1. And this should actually make sense because it's in group 1, which tells you how many outermost or valence electrons it has. So to get back to the octet rule, another way of thinking of the octet rule is that atoms want to look like noble gases. Okay, and sodium is not a noble gas. It is not in the far right column on the periodic table. But all of the noble gases have full valence shells. They have 8 electrons in their outermost shell. So sodium, which is element number 11, has 11 electrons. One of them is in its outermost electron. If it loses an electron, it looks an awful lot like the element just before it, which is neon, which is element number 10, which would have 10 electrons. So this sodium, if it can get rid of this 1 electron, it's going to become a positively charged ion. I'll show what that looks like on the next slide. But then it has a full outermost shell. It has 8 electrons in its valence shell, and therefore it is following the octet rule. Okay. All right, so let's quickly look at an example of how atoms will do this. And I've chosen a metal and a non-metal, which is something you should have also picked up on from the tutorial yesterday. Okay, so what's going to happen here is that the sodium, the metal, is going to give away, it's going to lose, you'll forgive me, I'm trying to type here or write with my touchpad, lose an electron. And you have to remember what charge electrons have, right? Electrons are negatively charged. So if you lose something negative, you will become slightly positive. So this electron right here, make sure you guys can track this. So this electron here is going to be given to fluorine. Fluorine is element number 9. It has 9 electrons. If it gets one more here, it'll have also a full shell. So people can usually tell, make it pretty obvious that if the electron gets dumped onto here, okay, and therefore, let's see if I can do some work here to get rid of this guy. What we end up with looks something like this. Okay, my apologies for the time taken to do this. All right, but now you'll see that since there's no one single electron on a third shell for sodium anymore, its valence shell is now its second shell. So it has 8 electrons in its second shell. Well, what does that mean? Well, it means that it has made its octet, okay? But it has 1 more proton than it has electrons. It didn't lose any protons, right? So it becomes slightly positive. We give this a +1 charge. It's slightly positive. Fluorine just gained this electron over here, and therefore it has 1 more electron than it has protons, and therefore it becomes a little bit negative. The reason why ionic bonds bond these 2 elements together, which a lot of you picked up on, is that these now have opposite charges, and so they attract each other. But the most important part I want you guys to understand is how they each get their octet. Sodium has an octet now because it lost its lonely electron out there on its valence shell, and then fluorine gained one electron, now making it an octet. What do both of these elements now look like in terms of their electrons? They look like the element neon. Neon is element number 10. It has 10 electrons and it has a full outermost shell in its second shell. So this is how each of these elements play the game of ionic bonds. This is why ionic bonds allow elements to make or atoms to make an octet and follow the octet rule. Hope that helps. Good luck today with covalent bonds.